Hello everyone, I wanted to post this quick video to show everybody how to do these concentration calculations that are going to be doing in lab this week. So first of all, let's take a step back and talk about concentration and specifically this concept of molarity, which is how we quantitate concentration. Okay, so one of the important things to remember about molarity is when we're talking about concentration, we're talking about measuring the amount of solute in a solution. So this is something where students go wrong with every once in a while, is they forget that we're always talking about solutions when we're talking about molarity, right? So sodium chloride all by itself does not have a molarity, doesn't make any sense. Sodium chloride dissolved in water, all of a sudden that solution will have a molarity, right? Likewise, a pure gas, chlorine gas, for example, doesn't have a molarity. But if we take something and dissolve it in water or in any solution, then all of a sudden we can talk about the concentration of that solution in terms of molarity, okay? So molarity is represented as a big M. And molarity is equal to the number of moles of solute dissolved in the volume or liters of solution. So what I want you to think of when you think of molarity is big M equals moles over liters. Okay, and again, moles, we're talking about the moles of solute or whatever it is that's dissolved in the solution, and the volume, the liters, pertains to the amount of solution, the volume of that solution. Just to note, another thing that we can, symbol-wise we use to talk about molarity are these brackets, okay? So this right here, sodium chloride in these square brackets, what that means when you see that is the molarity of sodium chloride. Okay, so you would see something like concentration of NaCl equals, 1.0 molar. Okay, that's my big M. It's just kind of messy. Okay? Okay, so let's make sure qualitatively we understand what we're talking about when we're talking about concentrations and solutions, right? So again, we're talking about solutes that are dissolved in a solution. So imagine here I have this box, this blue stuff in the background, this is just water, and then I have a bunch of these red solute particles dissolved into that solution. So they're just kind of floating around. When we're talking about the concentration, we're talking about how crowded those solute particles are. So notice that this box over here has this same volume, but it's just got more red dots floating around, right? So it's a higher concentration. There is more solute dissolved in this solvent than there is in this solvent. So this would not only, we would say this is high concentration, but this would also have a higher molarity. Likewise, this would have a lower molarity. So that's something to keep in mind. You could do sort of a sanity check with your calculations. If you know one solution is supposed to be more dilute than the other one, well, then the number you get for molarity should also be lower, right? Higher concentration means higher molarity, higher value to that molarity number. And we'll calculate values here in a second, but I just want to make sure everybody understands qualitatively. So then if, by eye, what are we talking about, right? Because we can't exactly see solutes floating around in solution. Well, you can imagine taking some food coloring and dissolving it into water, right? So this is what this picture down below shows. Here is maybe like 1 drop of food coloring, and over here we have like 20 drops. Right, so the concentration of food coloring is increasing as we're going, and you can see this visually, right? So the one all the way on the left, our most dilute, is just barely pink, whereas all the way on the right is incredibly concentrated with that red color. And likewise, same sort of idea in terms of this molarity value. This would have a low big M molarity, and this would have a high big M molarity. Okay? All right, so now how do we actually calculate this? So again, this is what I want you to think. You're gonna write big M equals moles per, and actually moles per volume, we can get even more specific than that. It's moles per liter. That's what the big M molarity stands for. You can also jump back and forth between these two quantities. We're really gonna focus on this today. But you'll be using concentrations of solutions in order to calculate moles or volume in various ways. This little triangle is supposed to be helpful in that respect, because if you want to calculate, for example, molarity, what you're going to do is you cover up that corner of the triangle, and you see that molarity equals moles divided by volume. Likewise, if we wanted to get moles of solute that are in a particular volume, then we would cover up this portion, and we'd see we'd have to multiply that volume by the molarity of that solution. Okay, so this is just a little helpful thing. Again, for this, we're going to focus specifically on how to calculate molarity, because that's what we need to do for our lab. Okay. So the easiest situation is when you're given your quantity in terms of moles. Okay, so for example here, what is the concentration of a 0.810 moles of hydrochloric acid dissolved in 1.25 liters? Well, again, what am I thinking? Big M equals moles divided by liters. And so that's exactly what we're going to do here. We're going to put our 0.810 moles of HCl divided by 1.25 liters of solution. And then we just punch this into our calculator. We get 0.648. And then if we look at our units here, notice that these don't cancel because they're different values here. So we are indeed left with our units of moles per liter, which is exactly what we want. Otherwise known as 0.648 molar. Okay, so one of the ways that we could do this, because we were talking about HCl, is to just put something like that. The concentration of HCl equals 0.648 molar, which we know moles per liter, that big M. Okay? Now, unfortunately, in the lab, we don't have like this mole counting instrument or anything crazy like that, right? So instead, in the lab, what we do is we measure the amount of solute in grams. Okay? So let's do an example here. So the first thing we're going to have to do is remember big M equals moles per liter. Well, how do I get from grams of NaCl to moles of NaCl? I'm going to have to use the molar mass, which I calculated here for you. Of course, you guys know how to calculate molar masses, so you'd have to do that, but I'm giving it here. So we start out with our 1.0 grams of NaCl. Oops. And then we're going to multiply that by the molar mass, and so which value is going to be on top, right? So this is grams per mole. That was a mistake, should have had that. But remember, we know which one we're going to put on bottom because we need to cancel out our units of grams. So we're going to put the inverse of the molar mass, where grams of NaCl are on the bottom. And we know to do that as opposed to being the reverse, because that allows us to cancel grams of NaCl. So if we stopped here, we'd have moles of NaCl. Awesome. Stopped right here, we'd have moles of NaCl, so that would be 0.0290. I'm going to take a bunch of digits just so that we don't incur any rounding errors, and I will just mark that we only have 3 sig figs. And this is now moles of NaCl, right? Because my grams cancel, and the only thing I'm left with is moles of NaCl. Okay, oops. Awesome. So now, the only problem is that I need to find out moles per liter, and I'm given milliliters, right? So then I have to do another unit conversion, where I do 25 milliliters, and then I'm going to multiply by the fact that there are 1,000 milliliters in 1 liter, and that would give me to 0.0250 liters. Okay, and then if I'm going to calculate the molarity, or the concentration of NaCl, that would just be these moles divided by the 0.0250 liters. All right, and then punch that into the calculator. 1.1635, but then I'm going to note that I have 3 sig figs in my moles and 3 sig figs in my volume, so I'm going to have to round it off here. So this would be in moles per liter, and so I get 1.16, and then we'll just make it that big M. So final answer is the concentration of NaCl is 1.16 molar. Okay, so hopefully this helps you guys out with your lab. If you guys have any questions, feel free to let me know. Okay, and so the last thing that we're going to have to go over is dilutions, right? So if you noticed in the experimental video, the experimental prepared what we call a stock solution of salt water. They did that by taking some sodium chloride, putting it into this volumetric flask, and then filling it all the way to the top with water, right? So this would be stock solution here. But then what they did is they used a pipette and took 25 milliliters of that stock and transferred it to a new volumetric flask. And then filled that up to the line with water, and this created our diluted solution, right? Which we can just see again visually compared to our stock solution, which is right here in dark blue. Our diluted solution has less of those solute molecules floating around. Okay, so again, she took some of the stock solution, transferred it into a new volumetric flask, and then filled to the top. So this is going to be a similar calculation where we want to figure out the molarity of our diluted solution, but we're going to have to do so a little bit differently. Okay, this is going to use this sort of infamous M1V1 equals M2V2 solution. Now let me just caution real quick. Most students in general chemistry, when they use this equation incorrectly, they get the wrong answer. This is specific to dilutions, right? So don't be tempted to use it at other points in stoichiometry. Okay, so how do we use this? So first of all, what do the 1s and the 2s represent? The 1 represents our stock solution, which is again the one that was more concentrated, the one that was prepared at the beginning, and then we used that to create our diluted solution, or solution 2. So when we say M1V1 equals M2V2, the 1s refer to the stock solution, so these guys talk about the stock, and these two terms over here talk about our diluted solution. Okay, so now what do these variables mean? So M is molarity. So M1 is the molarity of the stock solution. Okay, again, 1 representing our stock. It's this guy here. And then the V1 is, importantly, it's not the total volume of the stock solution, but the amount of stock solution that was used in the dilution. So in this case, it's represented by this arrow here, or a little pipette. In this case, it would be these 25 mils, right? Who knows how much of the stock solution was prepared? Maybe a full 1 liter, but only 25 mils were used. So that would be what the V1 is. How much of your stock solution is actually used. And then 2 is our diluted solution. We'll color code that as well. That would be what was prepared from the stock. M2 is the molarity of that diluted solution, and this is what we're going to be trying to find, right? We want to know what the, that was a terrible question mark. We want to know what the molarity of that diluted solution is. And V2 is going to be the total volume that we used. So M1, V1, and V2 are all going to be knowns in this equation, and then we're going to have to plug those values in and solve for the molarity of the diluted solution. All right, so let's do a practice problem real quick. So let's say a student is given 1 liter of 5 molar NaOH, and then they want to create a second, more dilute solution, and they're going to do so by placing 25 mils of the original solution into a volumetric flask, and then filling to a total volume of 100 mils. What's the molarity of that dilute solution? Okay? So if we just want to sort of diagram that out again, here's our volumetric flask. In total, we have 1.00 liters, and it is 5.00 molar. That's our solution. So here's our stock. Here's our dilute. And we're going to form the dilute solution by taking 25 mils of that stock solution and then filling to a total volume of 100 mils. 100.0, be good with my sig figs. All right, so M1 V1 equals M2 V2. We're going to go through and plug in the values that we need. So what are we going to use for M1? That's the molarity of the stock solution, so 5.00 molar, and multiply by V1. So what value should we use for V1? A lot of people would be tempted to say 1 liter, right? Because that's how much of that stock solution we have. But again, it's not how much we have total, it's how much we actually use in this dilution. So this would actually just be 25.0 mLs. That's what's being used in the dilution. M2 is again the variable that we don't know. And then we're going to multiply finally by the total volume of the dilute solution, which is that 100 ml. Now rearrange, I got to rearrange to solve for M2, so what I'm going to do is divide everything by 100 ml. Okay. Plug that into my calculator, and I would get 1.25. It should have 1, 2, 3 sig figs, 1, 2, 3, 1, 2, 3, 4. So 3 sig figs is correct. And then notice how units work nicely as well. Milliliters will cancel, and I'll be left with molar. So M2 would be 125 molar. All right, so that's how you would find the concentration of a diluted solution, again using this famous dilution equation, M1V1 equals M2V2. Again, just to caution, make sure that for V1 you're using the amount of stock solution that's actually used in the dilution.